Let's talk about another case. When product ambiguity becomes architecture, a health fintech case about unclear product direction, event-driven over-engineering, delivery chaos, and operational recovery. Software leadership case study. This is one of the clients I worked for a year and a half. And here I dissect, what happened, what were the problems I identified, my mistakes, etc. Product context, the product idea. A traveler has a medical emergency abroad. Imagine you travel to Mexico and you are from Spain or the UK. The insurer issues a digital payment card with controlled funds. So where you are going to be able to pay with that card, when, so the merchant, the time, region, which treatment, etc. Instead of you having the problem and waiting to come back to your home country in order to be able to claim back the fees or the charges. The user pays all hospital, pharmacies, and medical providers directly, with full control over who spends where, when, and how much. This is very important for insurers and for companies as well, because it reduces operational costs and also reduces timelines. And also people are on vacation, holiday, they don't want to be collecting documents and facing having to pay out of their pockets any medical treatment that usually they don't tend to be cheap when you travel abroad. The company will usually covers you, the insurance travel company, but it doesn't cover you in real time. That's the biggest problem. You have to have the money in advance in your bank account, credit card, whatever, and then you need to come back, claim, etc. This solves a very problematic issue for not just travelers that are on holiday vacation, but also international workers that are sent abroad to work. And this was a very good opportunity to cover their expenses. This was one of the verticals. The company has the potential to move to many other verticals. As I said, vacation travelers, worker, working abroad. So it's a medical emergency, issue payment card, pay providers, enforce controls. A compelling value proposition, but execution touch multiple regulated domains simultaneously. Probably the health industry and the finance are the most regulated and sensible industries everywhere, because they are treating people and a very complex systems that you need to conciliate other currencies, policies, legal problems, events that usually happen worldwide, a war or something like that. So it's a very controverted industries. Market complexity, a simple idea in a complex market. The user experience appeared straightforward, but delivering it required navigating 7 regulated domains at once, each with its own compliance, auditability, and availability requirements. So it was pretty simple. You issue a card and the people is able to use a card with controls. The problem is the very first customer for this company probably was an insurance company with 100 different travelers to 100 different destinations around the world. And you need to make sure that the car was working in every single location in real time and provision through the web browser. So the user experience wasn't that difficult, but the distribution compliance, that was where the problem was. Digital medical payment card, you have global availability, healthcare regulations, travel insurance, financial payments, tokenized cards, which was a pretty new technology, and web push provisioning is also, you need to request this kind of functionalities to Apple and Google respectively, Android and iOS. And that's not, you need to reconcile at the same time Visa or MasterCard and iOS and Android and wait for their time. So you need to have a very long runway in order to wait for all this and be very compliant. International merchants, third world countries are not well organized, as we all know, and identifying a merchant wasn't that easy, and controlling the card wasn't that easy. You needed to provide a lot of customizations. Compliance and auditability. Compliance, this is twice. Sorry, the complexity wasn't in the concept, it was in the intersection of all the domains within a single product. The system had grown into a technical maze, that was true. started as an MVP. The company would try to, find different ways to find market fit, but that wasn't especially a company thing, because every single company works the same way. While you are trying to find market fit, you don't really care much about code quality, extensibility, scalability, etc. You just need to present the product, demo the product, and make sure it works. Before strong technical leadership was established, the team had built many custom services, serverless flows, and event-driven components without enough product clarity to guide the architecture. That's true. That's true for every company, but if you don't have clarity, you don't create a serverless event-driven workflow in the first place. So the problem is, the main concept was that the company didn't want to spend on specific problems or specific products or MVPs, and they had in their minds that if they could create like a puzzle with different modules that they can interconnect and reuse, so they can change the product as they see market fit, then that will be kind of success. If that thing will exist, every company will be pursuing that. But that's not a thing in software development. That was a misconception that led to the maze. Before, custom infra, serverless, misuse, wrong DB choices. You don't want to use DynamoDB for relational information. Serverless is good unless you want to create a product that is not just an MVP. And also you want to use event-driven architectures, not to decouple functionality, but also to decouple domains, to decouple services. In this case, event-driven was used to plug this kind of granular functions so they can be plugged in, but then you ended up with many functions with 100 conditionals in it, because many different products were using the same function in a slightly different way. The only thing that was reusable was the name of the function. After, simpler architecture, proper data stores, clear boundaries, Event Bridge, Lambda, and SQS were used even for synchronous operations, creating a system that was hard to understand, test, and operate. Yeah, if you can do something synchronously, it will be orders of magnitude simpler than going asynchronously. And you need to ask yourself a lot of questions, and you need to have a very strong reason you want to go asynchronously. And there weren't good reasons in this case, where pretty much product desires that were not aligned with technology, like I said before, having this set of components that as modules that you can plug together and use event-driven architecture, so you can create like a tailored product with your different functions and reusing them. That's a misconception. That's not why you should use, or why anyone will use event-driven. Product trap, reusable modules before product clarity. The product team wanted reusable building blocks, as I said, that could be combined later, but real user flows and product boundaries were not yet stable enough to support those abstractions. Experiments were treated as reusable product modules, components, accumulated conditions, and special cases. Abstractions were created before the domain was understood. Developers ended up coding ambiguity. Basically, if you don't say to the developer, what to do, and you don't collaborate with the developer, or you create a lot of assumptions and you code on top of assumptions, then the assumption gets solidified in the code, and that becomes technical debt. It's much better to code minimalistic and not code in assumptions than saying, okay, let's code this and let's figure out afterwards if that was right or not. You need to figure that out before you put it into code. And if you don't know, put it in the code is not the first step. Otherwise, you will end up with this kind of thing. So the level 1 experiments treated as reusable modules. Level 2 components accumulate conditionals. Within, as I said, within a function, you have the different conditionals for the different products that were reusing the same function. Level 3 abstractions created before domain understood. It's like, yes, you cannot create, the abstraction of using event-driven. I found 7 different layers of event-driven triggers in one of the functions that was nearly impossible to follow or to debug, and the event-driven wasn't using even the letter Q. I'm not criticizing, I'm saying that the lack of understanding and knowledge led to introduce event-driven architecture where it wasn't needed, and also it was detrimental to the architecture and the business goal. And the level 4, developers coding ambiguity into the system. The delivery trap, the release process was a person. Basically, yeah, I cannot define that much better than this. It was a single person because instead of having a task or a ticket from the user value perspective described on a board, there were like 25 different tickets from front-end, back-end, database, etc. And then they were accumulated on the right side of the board, waiting for a single person to put a puzzle together to make something work, and then to be able to deploy that into production, the kind of freezing the development before releasing anything, because that person needed to put the puzzle. The development became a puzzle rather than something that you control, and you always have the user value focused, and also the why, why you are building this. So work was split into technical tasks, as I said. Instead of units of user value, release depend on a QA person manually assembling the puzzle before every deployment. Fragmented task, work splits across front and back end. So in a startup, you probably want to, instead of having different departments, so the least departments, the least silo people that you have, the better, because communication needs to flow. And if it's small, you are gaining speed by having the same person working full stack across one single functionality. And even more when you are discovering market, you don't need to create a perfect solution. You just need to develop something that it works, and any developer should be able to create a basic front end, basic back end with a basic database to see that if that will work. But if you start splitting your startup into front and back end, and you start having the communication complexity in between, while you are not that big, you are basically shooting your own foot. Work split across front and back end infrastructure and services, no end-to-end ownership. So basically everyone was, that's the typical problem that you would expect on any company that's splitting the work in this kind of way, but without the needed resources to coordinate all that. Misleading progress. Boards show technical activity, no user value delivery. So basically the board is owned by the product people. The backlog is what is left, or what are you planning to deliver next. But the problem is when your backlog is owned by the technical development team, and the product team don't understand or have any clue on how to read that backlog, because it's a bunch of technical tasks that you have no control on when they are going to be done, and somehow you need to picture in your head that the user value is some of the tasks that you see in the backlog, and you are always asking how many tasks I need to be able to see on the down column, so I will be able to know that something is already done and I can actually test it. And this is not because product needs to be on top of development, but the key and the main purpose of the board is to show transparently what the team is working and putting everyone on the same page. But if the board is owned by the developers and have very technical details that only developers can read, then what's the point of a product person reading that? The product person will always need to get reports from the development team whether something got done or not, but they cannot control that because they have no idea. Or they need to turn into technical in order to read and say, okay, I have my notes, or they probably need a board that maps the technical board, which is a terrible solution. Unclear environments where reuse incorrectly make clean testing unreliable. So if you have a pre-production environment, that cannot be your demo environment, because you will be blocking your way to production if pre-production environment is required while you are demoing something. And also the pre-production environment means that you should not expect 100% operability all the time. That's why you have pre-production, because you want to do the last test before you go to production. So you are putting at risk. The demo environment should be what you have in production with testing data, and you know that it works because it passed all the software development lifecycle. Not that you are presenting something to your clients that is midway to production with not all the tests, because then it's not that reliable. Manual assembly. QA manually connected everything before each release. A single point of failure. Basically, without that person, or also without that activity that person was carry on every deployment, deploying was actually impossible. Not deploying something that worked. not, you can deploy, fractions of a feature, but it wouldn't work. The pivot from fragmented services to a operable product path. We move towards a simpler, safer, and more understandable delivery model, one that reduced cognitive load and made the system operable by the whole team, not just the front end or the back end. Simpler architecture, Nest.js with S, with the backend, a monolith for the selected initiative, SQL where relational data made sense, object-oriented code structure, so to bring back the concepts that the business was building into code. So we coded what the business said, not having a kind of translation. Domain-driven design, basically. Modern infrastructure, we use Docker, Kubernetes, Argo CD, Git operations, consistent, repeatable, and auditable code. Before there was a complete customized, infrastructure deployment process with undocumented code that had to be thrown to the bin and starting from scratch. We couldn't start from scratch from the product perspective because we didn't have enough clarity from product to be able to develop what we had even though it was simple, to develop it again, because the answer was you can go through the code, do backwards engineering, figure out how things work, and then you can recode it. That will never result in something useful. You are moving from one trap to another if you do that. You need to have good grasp on how the product works from the product perspective, how the users are using the product, etc., not just thinking that a function is going to do that, and where it's going to affect. Clearly branching. Trunk-based development where appropriate, Git flow where serverless constraints required. We couldn't move to trunk-based. Was ideal, but it wasn't possible everywhere. Defined environments, clear separation, development, sandbox, and production, each with a defined purpose. We still use the sandbox environment as pre-production and demo. That's why we kept the name sandbox. But, we knew all the time what was in sandbox before. Frontend was pointing to sandbox when deploying to test, and then the backend when deployed to sandbox needed to redeploy the frontend, and we had lambdas that were connected to a frontend. It was a mess. Basically, this put clarity on the environments and how to use them and which role these environments play within this Git flow or the trunk-based selected flow. The result, delivery became clearer and safer. The changes made the system easier to deploy, roll back, understand, and operate. Technical ambiguity was reduced, and product ambiguity became visible for the first time. So basically, at the beginning, we have chaos everywhere, but once we started to put clarity on the development and the technical side, we started to see how this ambiguity and the assumptions from product side were actually causing or injecting this kind of, I would say, poison to the development team that was kind of forced to introduce this technical debt. I'm not trying to put to blame anyone. I'm just describing reality. If you don't give the development team the enough clarity to start even a development, and the majority of the things that you provide are assumptions, basically the assumption is actually you are describing technical debt because you don't know how it works. You are coding on some assumptions, and then if it doesn't work, then you come back and you retouch your code. But retouching that code because it didn't work, that's the definition of technical debt, basically. So product was enforcing technical debt because there wasn't a proper discovery mode or this discovery process before delivery. I mentioned this several times in my book. Tests, validated in sandbox environment. We introduced units, integration, and end-to-end tests heavily as part of the pipeline as well. Then build Docker images, built once and promoted through the different environments, not creating a Docker image per environment and per different deployment. That was happening before. Promote same image, move across environments, release and roll back, documented, repeatable, reversible process. Not for everything, but we had a very, the surface that we could control in order to be able to roll back in case of an error. It was being bigger and bigger. Docker images were built once and promoted across environments. Rollback became possible for both code and database changes. The deployment process became documented and repeatable. Basically, the team was using before, a process to create the queries or the changes in the schema on the database, and a different system which was type ORM to manage the database. There was a misalignment between the database schema and what type ORM was thinking the schema was. Type ORM is an ORM for TypeScript, and basically that discrepancy created some of the changes we created were not, or some of the code we wrote on top of this type ORM weren't actually possible on the schema we had. So we needed to synchronize this, and as I always said, whenever you have a problem in the database, that's the least and the most deepest layer in any development, and any problem that you have there, whether it's coupling different services through the database or not having a proper schema, that's probably the biggest technical debt that you can have, because once you change the database, you need to change the code, and vice versa, because one is coupled with the other. Unless you have a proper definition or distinction, hexagonal or domain-driven design, you can create. If you can keep your interfaces, you can change the connection to the database, but that's still, the repository is still very tied to the database, and then you need to recode a lot of stuff. It's a lot of work. Especially when you need to move fields, create database. It's not just normalizing, it's changing the schema and where the data is stored, and the logic of the schema. That changes completely. Even if you have interfaces and a proper architecture, that's a lot of work. Clear delivery exposes unclear product. Good engineering does not remove the need for product clarity. It exposes when that clarity is missing. The typical misconception happened here, that is, in Scrum or any agile methodology, you don't know whether the client will use your functionality, whether your client is happy with your functionality, or whether the functionality brings any value to your user. That doesn't mean you have no clue how to implement the functionality. It's like you need to know exactly how to build a house, but you don't know if you are going to be able to sell that house. You don't know if people will want to live in that house, but you need to know, like the palm of your hand, how to build that house. Because if you are wondering how to build a house and you don't even have that, how you are thinking you are going to be able to sell something that you don't even know how to build? Do you get it? Do you get me? So this is probably one of the biggest misconceptions about Agile. You jump into development without knowing anything. Know how to build it because you don't know the API. You just say, okay, I'm going to discover this as I go. That's the recipe for the disaster, because that's not Agile. That's naive. Agile is, I know how to build it, but I'm going to build the minimum so I can get feedback from my client and see whether it likes it or not, whether I need to iterate and add a room or add a furniture so I can, increase my selling points so someone can actually buy my product. But you need to know how to do it. And this was probably the very big misconception that was embedded in this team. When delivery is chaotic, it's easy to blame the technology because it's the thing that you don't understand. And if it's chaotic, then you don't understand it, and on top of that, it's chaotic. But once the system is operable, the real bottleneck becomes visible. Unresolved product decisions. Why is that? Why are we working on assumptions? Cannot we go and check and test the database, or test the API, or test the system, or create a front-end demo to see whether the clients need a functionality before going full into a development? Developers often end up coding the ambiguity that a product has not yet resolved. That is not a technical problem, it is a leadership one. That's, of course, we were probably sometimes 7 weeks into defining something that needed to be implemented without having details on how to do it. So basically we said we need a portal, okay, but how that portal will work? We can create hundreds of portals. So before fog and confusion, a cloud of fog obscures unclear product decisions, tangled architecture, and hidden complexity. Fog lifted, a clear delivery pipeline is revealed, exposing the remaining unclear product map. We created a full automated pipeline that anyone could deploy by just clicking a button, removing the dependency from that person, and moving from a technical board to a product-driven board. And what my mistake was that I always tried to keep myself within the software delivery part of the software delivery lifecycle, because I had other people that I was supposing them would kind of build that product discovery or that bridge, but that bridge was never understood. So the assumptions and the misconceptions were taken as the truth, and basically, if you are, so the problem is, if you are always blaming, that something is wrong and you don't see whether you are doing the right thing or not, then you just push back anything that anyone said to you. It's a people's problem. Not always you have a technical issue, bad developers, bad management, bad ideas. It's just bad execution because you are you put yourself on top of false expectations, false assumptions, false or misconceptions that led to these problems. This is not the first and the last time I faced this problem, for sure, because it's easy to confuse. Starting small with taking shortcuts. It's easy to confuse agile, that you don't know whether your clients are going to like it or not, whether you know how to build it or not. It's easy to say, I assume this, let's code this and let's change it afterwards, and you don't know about coding. And it's easy to think on modules while you don't know that creating a module that is fully 100% extensible to any context or environment is even harder than actually creating your MVP. But if you have those assumptions, basically you are doomed. You need to judge your assumptions before and try to get clarity in what you are trying to build and whether the approach you are taking is the right one. Otherwise, these problems are in the next corner. So that's the use case.